Given a string, we have to return the longest substring that is also a palindrome. A palindrome is a sequence that reads the same backwards as it does forwards. For example, if our string was hello, then we would return LL, since LL read backwards is still LL, and there is no other longer substring that is a palindrome. Now, one way to do this would be to calculate the length of every possible substring. So first, we'd find all substrings starting with the letter H, including the full word itself. Then we'd find all substrings starting with E, and we'd continue this until every substring has been found. This runs in O of n squared time. Then, we'd have to check every substring to see if it's a palindrome. Since palindromes read the same both forwards and backwards, we know that they have to be mirrored around the center. So one way to check would be to start at the center of each substring and work our way outwards, checking at each step to see if the characters match. For example, to check the substring LO, the middle two characters match, but when we move outwards, we see that the characters are different, so LO is not a palindrome. Now, each one of these checks runs in O of n time, and we'd have to do that for every single substring, which took O of n squared time to generate. So in total, the brute force algorithm ends up running in O of n cubed time. Now, we can improve this by eliminating some redundant steps. Here's the idea. Let's say we wanted to find the longest palindromic substring of ABCDEDCFA, but only considering substrings that have E as the center character. Well, if we know that the letter E by itself is a palindrome, then when we test DED, we don't need to start from the middle again. We can only check the outer characters, the Ds. And now that we know that DED is a palindrome, when checking the substring CDEDC, again, instead of starting from the middle all over again, we can just check the outer characters. Now when we check the next set of characters, we see that they're different. That means that this substring is not a palindrome, so any other longer substrings won't be palindromes either. So we can actually just stop here, and we don't need to check any more characters. In the brute force solution, we would have done the O of n palindrome check over and over again for every single substring with E as its center. But what we've realized here is that we can actually check all substrings with the same center in a single pass, with the potential to exit early. So now the question is, how many different centers can a string have? Well, if the substring length is odd, then any of the characters could be the center. And if the substring length is even, then the center could lie between any two characters. If the length of the substring is n, then there's a total of 2n minus 1 centers, which is O of n. So if visiting each center is O of n, and each palindrome check is also O of n, then that means that the overall algorithm will now run in O of n squared time instead of O of n cubed time. Now let's look at the code and see how we can do this in Python. Let's say ABAAB is our string. First, let's define a helper function called expand that will take in two indices that represent the center of the substring, and will expand outwards to find the longest palindrome from that center. We'll come back to this later when we use it. For now, let's create a variable that will hold our final answer and call it result, and we'll initialize it to the empty string. Then, we'll start the loop to check every center using the variable I. So now let's call the expand function and pass in the I variable twice, meaning that both the left and right indices in expand will start at the same index, 0. Then, we'll check for three things before expanding outwards. First, we want to make sure that we haven't gone out of bounds, so we'll check that the left index isn't less than 0, and that the right index is less than the length of the string. Those are true, so now we'll check if the characters at the left and right indices are the same. Right now, they point to the same character A, so this is true. That means that the substring A is a palindrome, and we can now expand outwards to check the next set of characters. We'll do this by decrementing L and incrementing R. Then we'll check again, but now we see that L is -1, so it's out of bounds. That means that we're done checking all substrings from the center, and we can now return the longest one that was found. We'll do this by slicing the string between the left and right bounds, not including the bounds themselves. So we'll slice from one index past L up until R, since Python string slicing includes the starting index but excludes the ending index. So we end up returning just the letter A. Now we return back to the main function, and sub1 is A. Now we'll compare sub1 to our result variable. If the length of the substring we just found is greater than the length of result, like it is here, then we'll update result to be sub1. In other words, the result variable always holds the longest substring encountered so far. We're not done yet with this loop though, because we now need to check for the case that the substring length is even, and the center lies between the first two characters. So we'll call expand again, but this time pass in I and I plus 1, so the center is between 0 and 1. Then we'll do the same thing. Both indices are in bounds, but the characters are not the same. A is not equal to B. So we'll just exit, and when we slice the string, we end up slicing from index 1 to 1, but remember, excluding index 1. So this actually ends up returning the empty string, since there was no palindromic substring to be found. So now sub2 is the empty string, which is not longer than the substring A, so we keep A as the result and move on to the next iteration. Now let's find the longest substring starting from index 1. B is equal to B, so we'll expand outwards and check the next set of characters. A is also equal to A, so now we know that ABA is a palindrome, so let's keep going. Now we've seen that we've gone out of bounds on the left side, so let's go ahead and return the substring between the left and right bounds. So now sub1 is ABA. The length of sub1 is 3, and the length of result is only 1, so let's update result so that it's now ABA. Then we'll try the next center between index 1 and 2. B does not equal A, so we just return immediately, again with the empty string, and skip the if block and move on. Now let's try index 2. Again, A by itself is a valid substring, but the next set of characters don't match, so we'll just return A, which isn't longer than ABA, so let's move on. Then we try index 2 and 3. Both characters match, so let's expand the substring. B is equal to B, so now we're at BAAB, and let's keep going. Now we've finally gone out of bounds, so we'll return the substring BAAB, and we see that its length is 4, which beats our current result, so we'll update result to be BAAB. Now the rest of the iterations are pretty much the same, so I'll speed this up a bit. A by itself is a palindrome, but not AAB, so we return A, which is shorter than BAAB. Next, AB is not a palindrome, so we'll just move on. B is a palindrome, and we can't expand out any further, so we'll return B, which again is too short. For our last check, we can see that the right index is already out of bounds to begin with, so we'll just exit immediately with the empty string. We've now checked every single center and found the longest palindromic substring overall, so we can just return the result, which is BAAB, and we're done. Now, for the sake of completeness, I will mention that it is possible to solve this in linear time using something called Manacher's algorithm. But it is pretty complicated, and I don't think any reasonable person would expect you to come up with this in a short interview session. But if you're interested, you can go ahead and check that out.